Lesson 3-3 is on proving lines parallel. Take a minute to read over the learning goal and find where you are on the scale before we start the lesson. In this lesson, we can use certain angle pairs to decide whether two lines are parallel. In the converse of the corresponding angles postulate, if two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So if angle 2 is congruent to angle 6, then line L is parallel to line M. In last lesson, when we proved the corresponding angles theorem, we needed two parallel lines intersected by a transversal in order for the corresponding angles to be congruent. If a transversal intersects two parallel lines, then the corresponding angles are congruent. Well, what if we don't know that the lines are parallel, but we do know that the corresponding angles are congruent? We can use the converse of the corresponding angles postulate to prove the lines parallel. So, if two lines and a transversal form corresponding angles that are congruent, then the two lines are parallel. In example 1, we will identify parallel lines. Which lines are parallel if angle 1 is congruent to angle 2? Justify your answer. Let's start by looking at angle 1 and angle 2. Since these angles are corresponding and they're congruent, the lines A and B are the parallel lines and line M is the transversal. So line A is parallel to line B by the converse of the corresponding angles postulate. Pause the video and do you try number 1. In you try number 1, we want to know which lines are parallel if angle 6 is congruent to angle 7. We want to justify our answer. Let's start by identifying angle 6 and angle 7. Since angle 6 is corresponding to angle 7, then line L and line M would be parallel, and line B would be the transversal. Notice that we didn't even touch this line, so it would not be parallel, line A. So line L is parallel to line M by the converse of the corresponding angles postulate. We can use the converse of the corresponding angles postulate to prove converses of the theorems we studied last lesson. Let's take a look at the converse of the alternate interior angles theorem. Here, if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. In the converse of the same side interior angles theorem, if two lines and a transversal form same side interior angles that are supplementary, then the two lines are parallel. And finally, in the converse of the alternate exterior angles theorem, if two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. Right now, you know two forms of proofs, the two-column proof and the paragraph proof. In a third form, called the flow proof, arrows show the logical connection between the statements. Let's practice by proving the converse of the alternate interior angles theorem. We want to start with the given. Angle 4 is congruent to angle 6. Our next step would be to say that angle 4 is congruent to angle 2 because they are vertical angles. Since angle 2 and angle 6 are both congruent to angle 4, angle 2 is congruent to angle 6 by the transitive property of congruence. Since angle 2 and angle 6 are congruent corresponding angles, we know that line L is parallel to line M by the converse of the corresponding angles postulate. In example 2, we will write another flow proof. Let's start with the given. Angle 1 is congruent to angle 7. Next, let's take a look at angle 3 and angle 1. Angle 3 will be congruent to angle 1 because they are vertical angles. Since angle 3 and angle 7 are both congruent to angle 1, they are congruent to each other by the transitive property of congruence. Since angle 3 and angle 7 are congruent corresponding angles, line L will be parallel to line M by the converse of the corresponding angles postulate. Pause the video and do you try number 2. Alright, in this flow proof, we want to prove that angle 3 is congruent to angle 5. Let's start with the given. Angle 1 is congruent to angle 7. In our next step, angle 3 is congruent to angle 1 because they are vertical angles. Since angle 3 and angle 7 are both congruent to angle 1, angle 3 will be congruent to angle 7 by the transitive property of congruence. Since angle 3 and angle 7 are congruent corresponding angles, line L is parallel to line M by the converse of the corresponding angles postulate. And finally, since angle 5 and angle 3 are alternate interior angles formed by two parallel lines, they are congruent to each other by the alternate interior angles theorem. In example 3, we will be determining whether lines are parallel. The fence gate at the right is made up of pieces of wood arranged in various directions. Suppose we know angle 1 is congruent to angle 2. Are lines R and S parallel? Explain. Since angle 1 is congruent to angle 2, and they are alternate exterior angles, we know that line R is parallel to line S. So line R is parallel to line S by the converse of the alternate exterior angles theorem. Now pause the video and do you try number 3. Since we were given that angle 1 is congruent to angle 2 in example 3, and now we're looking for another way to prove line R parallel to line S, let's look at the relationship between angle 3 and angle 2. Since angle 2 and 3 are vertical angles, angle 3 is congruent to angle 2. Now we can see that angle 3 is congruent to angle 1. Since they are corresponding angles and they are congruent, line R is parallel to line S. We can also use algebra along with our postulates and theorems to solve problems involving parallel lines. Let's look at example 4. What is the value of x for which line A is parallel to line B? Let's start by saying if line A were parallel to line B, then my same side interior angles, 2x plus 9 and 111 degrees, would be supplementary. So let's start with that equation. We'll combine like terms to get 2x plus 120 equals 180. Now we'll use the subtraction property of equality to get 2x equals 60. And finally, if we use the division property of equality, x will equal 30. Remember, we should always substitute x in for our expressions in order to check. Since 2 times 30 plus 9 plus 11 equals 180, we know we are correct. Pause the video and do you try number 4. What is the value of W for which line C is parallel to line D? Let's look. Since these angles are corresponding angles, they would have to be congruent if line C were parallel to line D. So let's start by setting 55 equal to 3W minus 2. We'll use the addition property of equality to get 57 equals 3W. Finally, we'll use the division property of equality to get 19 equal to W. Remember to substitute 19 in for W in our expression or your original equation to make sure that you have the right answer. Since 55 does equal 3 times 19 minus 2, we know we are correct. Now is your chance to prove how well you understand this lesson. Go ahead and do the lesson check. Don't forget to check your answers. If there are any questions you are unsure of or don't understand how to do, please ask me tomorrow in class. If you're feeling up to it, give the challenge a shot. I'm pretty sure you can do it. Now that we've completed the lesson, reread the learning goal on the scale. Have you upped your level from when we started the lesson?